Okay, got it.
So that's just one bit of like the things that you probably want to avoid in running unit tests. But let's start with like what is a unit test? Because before we can write unit tests, we need to understand what it is. A problem, well defined as a problem solving. Has anyone seen this before?
Yes.
Yes.
No.
Essentially, no. So a couple of points from here actually, if you analyze this a bit more. And that's actually a good description of what unit test is. It tests just one thing. It doesn't actually care about the system. It tests just the small bit of functionality, which means it's not complete. But also that's a trade-off. It doesn't mean that if you write unit tests with complete coverage that's enough for your system. You actually still need integration tests because it would not necessarily mean that you've covered everything. This is one definition. There's many definitions. I like this definition because it's probably the only one that talks about unit tests being automated. You can actually test individual functionality manually, but I don't think that makes sense in nowadays. A unit test is an automated piece of code that tests a single assumption. So, knowing what unit test is, where does it fit? What is the sweet spot? We know that we need integration tests, but what kind of things do we want to put unit tests against? These are the three, at least, things that I think make sense to put unit tests against. When you want to do business logic, not presentation logic, not view, not whatever, when you want to talk about business rules, typically the right place where you want to put it is unit tests. So you would cover, typically because business logic and business rules, you want to cover different scenarios. You want to cover, especially what you say, the permutations, the different ways you can actually apply the business logic. But you don't care the business logic on whether or not that business logic comes from the user input, whether or not it comes from a file, whether or not it comes from a database. No, you just want to test the domain logic or the business logic. Usually, unit test is good for edge cases as well, when it's like boundary values, or you have a lot of cases where, let's say input is not what's going to happen. Let's say input is undefined, what's going to happen. Let's say the date is out of range, what's going to happen. Permutations as well, which I talk about with the business logic stuff. Why do you unit test? We're going to cover pretty much the first 3 points. The fourth point, not very much about unit test is actually important for design. But really, when you have unit tests, especially automated unit tests, you run it, it gives you confidence when you make a change because typically it'll cover business value. And that's the next point. When you write unit tests, the reason why you want to write unit tests is it protects business value. And that's how you think about unit tests. It's like, okay, I'm going to ship it to production in order in the future such that the business value won't be affected. What will I do to be able to guarantee that, or at least prevent the business value from being regressed? So it's almost like preventing regression. And communication to the next developer as well. Task as specification. You come in, you write good tests, you write like what this test is supposed to do, you write a good test description. It'll tell the next developer in the sense, okay, oh, this piece of code is doing this bit. I understand. If I want to put up some more logic, it probably makes sense if I put it here. It also drives design as well, especially if you TDD it, because usually testable code is maintainable code, but we're not going to talk too much about that. So, how to annoy the living shit out of the next developer? This is unit test anti-challenge. This is pretty much the crux of it. How not to write unit tests. So, this is my biggest pet peeve. It's low coverage. When you get to a piece of code, and if I see a code and I say, okay, this code could have break, and no unit test would have tell me that this code would break, or this code would no longer deliver the functionality that it wants, and there's no test that breaks. I can comment one line, and that would totally break the code, but no test would tell me that it's broken. That is not a good thing. So you do need some sort of coverage, but coverage in the sense that those who are protecting the system. This is the next bit, and this is to Shiram's point. Tests need to be dumb. So when unit tests becomes too complicated, that the logic itself needs to be unit tested, you're doing it wrong. This is another anti-pattern. unit tests needs to be predictable, needs to give consistent results, and unpredictability is something that you don't want out of unit tests. So anytime you use something that either side effect, we talk about side effect later, but that you can't guarantee for every implication it's going to give you the same result, then you need to be suspect with it. For example, time.now, math.random, anytime you do wait or sleep, or anytime you access file system, database, I/O, or external services, you need to be very, very suspect. You might want to test them still, but it doesn't live or it doesn't belong in the unit tests. Side effect. So, yeah. Similarly, anti-patterns in unit tests, whenever you do a file create, file update, file delete, which is what you do with I/O operations, for example, anytime you modify global variables, you need to be suspect as well. And anytime you do database resets or updates and mutation, you also need to be suspect. These are typically what's going to be painful, but you don't realize it. Because let's say you're using database, this is for unit tests, not integration tests. Let's say you're using database and then you put the database into a certain state. And then the next time you run the test, you forgot or whatever, and then the test breaks. So during several implications of unit tests, you can't guarantee the precondition of the test because of these side effects. Noise is another big anti-pattern. And there's a lot of categories of noise, but these are a couple of examples. Whenever you do a huge setup, or if you have the test being really huge, or if you have multiple assertions, and chain tests. Does anybody know what chain tests are?
Yeah, you want to assert order.
Yes. Or in the test, you have multiple assertions, but you do one thing, you assert, you do another thing, you assert, you do another thing, you assert. And duplication. And duplication. And duplication. So here's a huge setup example. So the test really is to test the beer color needs to be yellow. But in the precondition of the setup, you said, oh, you need to ferment the ale, crush the hops, mix the ingredients, bottle the beer, stick to the label, pack it in the box, sell it to the store, purchase the beer, apply the discount, bring it home, stuck in traffic, and actually drink it. And in the precondition, makes sense in this context. So similarly, let's say you don't have the precondition, huge setup, huge test. Same thing, it's just not in the setup, it's in the test. Multiple assertions. It should be yellow and crispy and liquid and magical, for example. So in this case, after you do your precondition and set up your test, you test for 4 things. And there's multiple reasons why this is probably not palatable or is an anti-pattern, or the next developer will be confused. Primarily, it's because there's multiple reasons why the test can fail. So you have one test, it could fail because of the taste, it could fail because of the color, it could fail because of the same matter, or because of plus. That's more of a guideline when people write tests. It's like whenever you see an and in the description, either before or after, you need to be really obsessed because it's probably not going to be even tested. This is chain tests. So you do, it should be correct. It says ferment ale, expect ale to be fermented. Crush hops, expect hops to be crushed. Mix ingredients, expect ingredients to be mixed, etc. And then at the very end, expect beer color to equal yellow, drink it, expect belly to be full and beer to be empty. Multiple assertions, but you need steps between the assertions. They can probably be separate tests instead of one mixed chain test. And plus, when you do this, usually you find it really, really difficult to name the test, because then it becomes too generic. Then, again, same thing. You lose the value, and then it becomes really difficult. Duplication. There's actually 3 duplication here. And I'm curious whether people can actually see what the duplications are.
Fridge, new person, new and gender name.
Yeah, there's 3 categories of duplication. So one is the code is duplicated 3 times. What's the other duplication?
The name of the first one.
Yeah, that's similar category of it being copied and pasted.
They all expect the same thing.
Yes, that's the second category. But typically with this one, should return no beer allowed for male 11 and should lock the fridge for male 11. Because the assertion here and here is the same. So this is, when you write a test, if it's already asserted in other tests, you don't want this to be asserting it as well. Because if this particular logic is breaking, then 2 tests will break instead of 1. So typically you want one particular logic to be covered by 1 test, unless it's for boundary cases, edge cases, or permutations. But typically you want just 1 assertion. And you don't want to repeat the assertions that's already been done from other tests. So we have, one is this pretty much the preconditions are duplicated. So you could probably put it in a setup or something, or a convenience function. This assertion is duplicated between the 2 tests. The third category is description between implementation. So you're duplicating what you say in the description with what you actually implement in the test. And typically people don't see that. So what you're saying here is should return no beer allowed for male 10. Here it says no beer allowed. It says male and 10. And the reason why it's not palatable is because you don't have that single source of control anymore. Typically the test needs to be the single source of control. And this should return no beer allowed for male 10 is actually a specific case, which sometimes is okay, a specific case of a business logic. What really you want to protect here is underage is not allowed to have beer. Not no beer allowed for male 10, which is a little bit too specific with regards to the testing, in my opinion. So the reason why it's dangerous is, firstly, when people copy and paste, they might forget to change the description, or when they change something, they might forget to change the description. If the description instead says should throw when underage tries to drink beer, then irrespective of your implementation in the test, you don't have to change the test description, as long as it still describes what the test intent is.
I have a question.
Sure.
How can you improve this? So basically, the first one should be no beer allowed for underage. Fine.
Mm-hmm.
What if in the second one I have values that I want, why I want to cover 11? How should I manage that now?
That's a good question. Then, with the description of male 11, it doesn't tell you why you're testing male 11, right? So let's say the intent is for boundary value.
Correct.
Then you should tell the next developer that this is for boundary value, not male 11. Because male 11 doesn't tell me anything.
But no beer allowed for underage for testing for boundary value.
Let's say the legal age of drinking in La La Land is 11 years old, for example. Or 11 and a half. And then you're testing the boundary value of 11. So the fact that you're asking why you're testing male 11 proves my point that this test is not clear. If you're testing for boundary value, then you need to say that it's for boundary value. If you're testing for units over tens, for example, I know that this code is able to test for 10 years old, 20 years old, 30 years old, but I don't know if they can test for 11, 12, and 31, 32. Then you need to explain that in the test as well. Instead of just saying no 11. It doesn't tell me anything. And in the implementation, fine, you can do whatever you want. But first of all, it's duplicated. Secondly, the test name doesn't tell me what business value I'm protecting. Cool. Coupling is a huge other area. So these are several areas where coupling can occur. Leaking implementation details, complexity hiding, which is actually a bit of a gray area. Smart mocks, back to your point, Sharam, about tests need to be dumb, code need to be smart. Exposing private properties for mutation, which means you have a class and it's really difficult to be able to test without actually cheating. So there's a private internal thing that you need to expose and then you mutate it in the test and then you test again. That's usually not good because it's coupling again, right? You're coupling the test with the implementation and exposing private attributes for inspection. Usually this bit about coupling is about test brittleness, which means anytime any of these anti-patterns is applied or any of this anti-pattern is manifested, you now put an additional barrier for the next developer to refactor your code, to make changes, to make additions. Because coupling essentially is a barrier to change. Now the test knows too much about code. If you change the code, even though it doesn't change the outwards, for example, outwards output or outwards behavior side effect of the code, you're still going to need to change your test because it breaks, even though it doesn't break. Unit test needs to break when business value breaks, and when the business value doesn't break but the unit test break, you're doing it wrong, in my opinion. So here is linking implementation detail. Usually it would be in the realm of mocks, but it could be in any other areas. Let's say you have a fridge, it needs to serve the beer cold, and then the fridge requires several things like a compressor, and converter, and a light. And then you create a new fridge with the compressor, converter, and say, hey, when the compressor runs, you need to circulate refrigerant coolant. When the converter run input, it needs to convert it to 20 volts to 1,000 watt motors. And when light is invoked, when the door is open, then it needs to return on. Firstly, it's noise. Doesn't care about the test. These are like, and secondly, it's implementation details. If the fridge happens to be something that uses an inverter instead of a compressor, then this test needs to change, even though the beer is still cold. So the output of the fridge being served, the beer being served out of the fridge is the beer being cold. That's the business value that you want to protect. But the implementation of the fridge should not break the test of testing the beer being cold out of the fridge. Hiding complexity is a bit of a gray area. So let's say you now have a fridge test set up that pretty much does what I did before in terms of the compressor run and the compressor input outside. And then you have a beer fridge and you have a soda fridge. And then pretty much what you're saying is now you reduce the noise from the test in beer and soda because the duplicated thing is now outside in a different test. So this is a trade-off. That's better than the previous code because you reduce the noise. That's better than the previous code where it has duplication because then you have single point of control. But whenever you do a reuse or whenever you have a single point of control, the trade-off there is lack of independence. So these two tests no longer have independent destinies. So anytime, let's say, a fridge setup needs to be set up perfectly for a wine fridge, let's say it needs to have a temperature control for a wine fridge, which is about 15 degrees or 12 degrees, that now affects the beer fridge and the soda fridge as well because it uses the same fridge test setup. Anytime you change here, anything here for one specific test, it would actually affect other tests because it's used in other tests. Smart mocks. So here is an example of, let's say instead of the actual implementation of a class, you create an alternative implementation. You usually call it test doubles. And in other tests, for example, you have a test API somewhere that you can hit. In this case, you create a fridge double, and then usually it becomes smarter and smarter depending on whether this test is used in different scenarios or whether there's separate steps that needs to happen. So because when you have a double, usually you want to say, okay, I want my code to behave correctly with regards to my interaction with the double. I want my code, which is like the user, for example, the user code, I want my code to behave correctly with regards to the fridge. Like if I open the fridge needs to be open. If I take something out of the fridge, then the inventory should decrease and I can see stuff. Even though it's not a real fridge, it's a virtual fridge. And when you do this virtual fridge, in order for you to have that sequence of interactions, sometimes you do need to do this hacky thing. It's like, what happens when things are warm? That means you return warm urine disguised as beer. Or what happens if it's a soda fridge? Oh, it's going to give you a different behavior. So unfortunately, this is complexity in tests. So mock, especially smart mock, is no longer a double. It's an alternative implementation of the thing. It's not something that stubs out and just dumb gives you a value. It's actually something that interacts. Something that interacts means you have logic, you have case statements, you have if statements. That means bugs can actually leak into this stuff. So complexity increases, the confidence that you have against your test would increase. There's a couple of gray area. So it can be good, it can be bad. It's not really an anti-pattern, it's never black and white. So there's always a thing, typically when we talk to a lot of developers about whenever you need to modify your code in order to satisfy your test, then that's just not. It's a bit of a gray area because that's pretty much the whole tenet around TDD, because you want to write your code to be testable, and usually a testable code means a maintainable code. So that's why it's in a gray area, because sometimes when you modify code to be testable, it's actually for a good thing, but sometimes it can also be a hack, like exposing private properties for mutation or exposing private properties to be read. So exposing private function, maybe, maybe not. If it allows you to test and gives you the business value and the confidence, then yeah, it's a good thing. But if because you expose the private function, then every other code in your application knows about your private function, then that's the trade-off.
Unless you use interface.
Yeah.
Isn't the pattern to just make it protected or package visible then, so that your test can see it?
Depending on the language. But again, when you said package visible or protected, yes, that's because the language allows you to do that. But at the same time, why isn't it entirely private, for example? So when you make package visible or protected, why is the class that inherits it need to know those variable from the parent? Same question applies. If it's only for test, then that's where we're like, I'm not sure.
I was referring to function.
Similar, both cases.
So the use case was something like, I'm calling this one function which invokes another private function for some sub part of that behavior. I want to test that at the unit level. So I expose that instead of a private, I make it protected, and I write a unit test against it.
Sure.
So that kind of test, this subpart also works
Yeah.
independently.
So when you make that decision between making it into private and protected, that's personally is a case-by-case basis. Secondly, let's say outside the context of test, why would you make it into protected? So if the only reason for making the private to protected is for test, then that's where you're gonna need to be a bit more careful. Why do you need to do that? Assigning ID to locate element. So this is where, let's say you want to test the presentation layer in a unit level, and then you want to say, okay, when unit is this, then the label needs to be that. Or sorry, when the input is this, the label needs to be that. And typically with HTML type of scenario, you would say, it needs to be a div, which is 3 levels down from the form, and then it needs to have the class that. So another strategy is just tag it as test label. And then that means your test is going to be more robust when the structure of the HTML change. But at the same time, now you have this thing, class test label, that lives in the application. So that's the trade-off there. One strategy that people use is have a parser that pretty much grabs all the test label before it goes to production and just gets rid of it. Another one is dependency injection. I think it's always good to separate creation or instantiation logic, especially for third-party collaborator outside of the code. So like just now with Fridge, you actually inject compressor, converter, and light. It's always a good idea in terms of design because you don't want the instantiation of those actually living inside the Fridge class itself. But when you try to do dependency injection for the sake of testing, I think that's a bit of a gray area as well. It's almost the same thing as like making things interface just because you can mock it. So interface have other reasons why you want interface, but when you mock it, when you introduce interface just for the purpose of mocking, that's where you need to be careful as well. Start thinking about why you're doing that. Custom assertions is another thing, which means your test becomes more complicated, and then you say instead of assert something equals to something, you say assert this is correct, and then you have like an entire different function to assert whether or not this is correct, either deep equal or something. Again, complexity, and you're hiding the complexity. And we've already talked a little bit around abstractions to hide complexity. So quick guidelines. Here are just a couple of questions, suggestions. Whenever you want to write unit tests, what do you need to think about? So you're writing a unit test. Yes, you're writing it so that things can fail when it's not giving you the results you expected. But what you think about is like, in what ways can the code change? Is it in terms of the parameter? Is it in terms of the value? Is it in terms of the structure? Is it in terms of different validations or business logic that's going to happen. And then when you think about in what ways can the code change, then you think about how to write tests in order to protect against those changes. So let's say the code can change, I don't know, a misspell, and the code can still be green, and because of that misspell, the whole application break. Can you write something in order for you to protect against that typo or misspell? Another way is like constant values. If the constant values need to change, and then that's going to break tests, can you write against that as well? Sorry, if the constant value can change and that breaks the application because of business value, then can you write tests to protect against that? Oh. How will this test be read by future developers? Because the idea is about communication. What context do they need? Inside the test itself, there should be enough information. And how do I communicate my intent? What business value I'm protecting? And in what? So another thing is sometimes the test is always green. And that is also bad because you can never change the code to fail the test. That means the test can never fail. That means the test has no value. So if the test can never fail, then it's a useless test. So similar thing, you need to ask, okay, in what ways can this test fail? Can it even fail? When it fails, does it fail independently? And finally is, this is more about deciding which areas you put the test in. Can the test be green with a broken code? So can you change the code in such a way that the code breaks, but all the unit tests will pass? And if you can't write it as a unit test, then that's where you need to think about different levels, like integration tests or functional tests. And with that, thank you.